Hello or welcome back. I hope you had a lovely half-term break and everything's good with you and your families and all of that. We are going to be having a look at trigonometry today, your basic right angle trigonometry, or SoH CaH ToA as some of us like to call it. But before we do, got a little bit of a mental arithmetic style puzzle for you to have a go at, one of the tougher ones. So let's have a little go and we'll see how we all get along with that. Here's the puzzle then, so pause the video and have a little think of that, and then I'm going to talk you through how I would do it. Well, first of all, straight away notice this is 77. So 2 multiplications to get to 77 can only be 11 times 7, which means that this must be a 7 here. Those two must add up to 11. We've already got the 8 gone. What next? Notice we've got 41 down here and taking away, so these two numbers must multiply together to make more than 41, and we've already had the 7 and the 8 gone, so we've got a 6 times 9 gets us 54, 5 times 9 gets us 45, so it can only be one of those two. But it can't be 6 times 9 because 54 is too big to take down, so it's got to be 9 times 5. And it's about working out which way round. Is it 5 or 9 up there? And you may try a little bit of one or another. And if we have that, and so 2, what do we add to 6? We add 6 and 5 and 2, because 2 times 9 is then 18, isn't it? And 18 take 1 is 17, 45 take 4, and I must admit I did a tiny bit of playing around, trial and error, just to one side a moment ago, so that's all fair too. 6 take 3 is there, and they should all work. Right, time to move on to some good old trigonometry. Now, whenever you're dealing with trigonometry, you know it's trigonometry if it's a right angled triangle and angles are involved as well as sides. If it's just you've got 2 sides and you want to know a third, you can use Pythagoras. Now, SoH CaH ToA, whenever you realise that you're going to need trigonometry, start by writing out SoH CaH ToA, and then you need to know that SoH means sin of the angle, which we use that symbol for, is the opposite over the hypotenuse. Cos of the angle is the adjacent over the hypotenuse, and tan of the angle is the opposite over the adjacent. So there are 3 different combinations you can have. And the hypotenuse is always the longest side, which is always opposite the biggest angle, which is always the 90-degree angle in a right angle triangle. So that is the hypotenuse. So start by labelling the sides. The opposite one is the one that's opposite the named angle. So the named angle is either the one you want or the one that you've got a value of. So we've been told that's 35. So this is the opposite, and the adjacent will be the one along here. Now we don't want the adjacent, and we're not told what it is. We know the opposite, we want the hypotenuse. So that means we're dealing with the opposite and the hypotenuse. Now you look at SoH CaH ToA, and the opposite and the hypotenuse are involved in just one of ToA, just one of CaH, but both of SoH. So we're going to be using SoH. So we can say sin of the angle is 35, is equal to the opposite, which is 20, over the hypotenuse, which is x. So now we need to rearrange the formula. Some of you may be happy just swapping x and sin 35 over, or you may want to multiply by x to give you x sin 35 equals 20, and then divide by sin 35 to give you x equals 20 over sin 35. You then get your calculator, make sure it's in degree mode, hit the fraction button, put 20 on the top, go to the bottom, sin 35. They open a bracket there, so make sure you close that bracket and press equals, and it gives you 34.86 something. It's not telling you what it wants you to round it to, but so if they don't, then just do it to 3 significant figures or 1 decimal place. Doesn't matter which one you call it, as long as you name what it is. So it's 34.8 centimeters to 3SF. Right, let's have a go at question 2. Pause the video and see how far you get. So you should have the fact we've got SoH CaH ToA. It's the opposite to 42. It's the one that's adjacent to 42. This is the hypotenuse, which we don't want. So we want the opposite and the adjacent, which is ToA. So that means you're going to say tan 42 is equal to the opposite goes on the top, that's x, over the adjacent underneath. This one's a little bit simpler because all we have to do is multiply by 11 and we get 11 tan 42 equals x. Pop that into your calculator like this. Make sure you close the bracket on the 42 degrees, press equals, and you get 9.90. So 9.904 rounded to 3 significant figures, 9.90 centimeters. So we're going to do all of these to 3 significant figures since I haven't said otherwise. Moving on to question 3. Pause the video, give it a go. So here again we've got the hypotenuse, we've got the adjacent, the opposite is irrelevant, so we are looking at the A and H of CaH. So cos the angle, now the angle this time is what we want, so you write cos x equals, the adjacent goes on the top, the hypotenuse on the bottom. Now this is a possibility to get a mass error in your calculator if you do it the wrong way round, because it's impossible for the adjacent to be longer than the hypotenuse. So now to find out the angle, there is a bit of a clue in your calculator. When you go to cos, just above it says cos to -1, which is the inverse of cos, which is what you need to do to find out what x is if you know what the cos of x is. So cos to the -1, 16 over 24, pop that in the calculator, shift cos 16 over 24, close the brackets, equals 48.18. I'll write down, and then that's we're going to call 48.2 degrees. There you go. Here's question 4. Pause the video and give it a go. Notice I'm going through the same process every time, and I really recommend that you do this. Always, in some ways it makes it easier, just makes it easier, because you're not having to think too hard if you know you're going to be writing these things out, which you know without even thinking. So you've got your ToA, so I know that that is tan of the angle, so tan x is equal to my opposite, which is 15 over 11. And if I've written that down like that, I'm much less likely to make a mistake. So x is going to be tan -1, 15 over 11. Put that into your calculator and you should get 53.74, and I am just going to round that from there. 53.7, that rounds to, doesn't it? And that is degrees because it's an angle again. Great, now on to question 5. Pause the video, give it a go. Before we go on, I've just noticed this is the point of, this is why it is worth putting that box around and writing down the next degree there. At the time I made a mistake, but looking back now, just glancing across, I suddenly realised, hang on, I haven't rounded that up. I should have rounded it up. I'm sure there are those of you who noticed that at the time. So that should be 34.9 centimeters. Right, carrying on with question 5. So I've done my SoH CaH ToA, I've labelled my sides, I've even put an X on AB because that's what that's my distance that I'm trying to find. So it's opposite that I want with the adjacent as well. So it's tan 35 equals X over 20. I then multiply both sides by 20 and I get 20 tan 35 is going to be X, for which I have got 14.00, so put the box around, it's definitely staying down as 14.0 centimeters, and I do need to put that 0.0 in because it's not exactly 14 centimeters. Last one on the first page, pause it and have a go. If, by the way, this is too quick and you feel like you need to know more because you never really quite got trigonometry, please do let me know, and if there's a few of you wanting to do it, I can do another video for slightly slower going through what we're trying to do. So I want the length AB, which is that one there, and this is the adjacent because it's next to the 2-degree angle. That's the hypotenuse. Don't want the opposite. So A and H is CaH, so it's cosine 1. So filling that in, we've got cos 42, cos of the angle, equals A, which is X, over H, which is 15. Multiply both sides by 15, I get 15 cos 42 is equal to X, and pop that in the calculator, which gives me 11.14, which rounds to 11.1 centimeters, and always remember to put your units in. Question 6, pause the video, give it a go. This time it's telling you the angle, so the angle is there. So the one next to it, which is not the hypotenuse that's touching it, is the adjacent. The other one that's touching it is the hypotenuse, and so this one over here is the opposite. So we don't know anything about the opposite, we do know these. Adjacent and hypotenuse is CaH again. So cos X equals A, which is 5 over 16. And then we need to do the inverse of cos to get X on its own. It's like dividing by cos in a way. So pop that into the calculator and you get 71.79, which rounds to 71.8 degrees. Always double check whether or not it's an angle or a length that you're trying to do at the end. Right, moving on to question 8, pause the video, give it a go. Again, we have SoH CaH ToA, and we are looking at ACB, so C being in the middle there, call that one X, and that means we've got the adjacent and we've got the opposite, with that being the hypotenuse, which is irrelevant in this case, so it's a ToA job. So that's tan X is equal to, now tan is the only one where you can have a smaller number on the bottom, but in this case the smaller number is still on the top, 5 over 9, so X is going to be tan to the -1 of 5/9. Pop that into your calculator and you should get 29.05, which rounds to 29.1 degrees. Now if you're not getting any of these values right, it may be that you're not in degree mode. So just quickly to run that by you, in order to get degree mode you want to press Option and then 2 for angle unit, and 1 is your degree mode, 2 is something called radians, and 3 is, oh, ask your scientist what that G means, can't remember. Anyway, it doesn't matter. So you want to make sure you're in 1 degree mode in order to do that. Actually, I just realized that's just if you want to type a degree in there, or say it's something. If you want to check, you see I've put it in radians mode. Now actually I did that by going, not by doing options, by going shift setup. So next to the menu key, then go angle unit, which is number 2, and then press 1 for degree, and you notice that's changed to a D there, so it will now give me degree mode, the proper numbers. Anyway, pause the video, give this one a go. Right, working out the size of angle BAD. So, that's that angle there. Well, pause the video and give it a go. It's about being creative. You need to draw an imaginary parallel line to that across there, because that'll give us a right angle there and there. And if I call that X, I can say that BAD is going to equal X plus 90. And then I need to use SoH CaH ToA to work that out. So I know my opposite because that's 4 and that's 6. So the opposite must be 2 and the adjacent is 15. Opposite and adjacent is tan again, so tan X is going to equal 2/15. So it's going to be a very small angle. X will be tan to the -1 2/15, which should give you 7.59 degrees. So if we add that to 90, that would give us 97.59, and I can round that to 3 significant figures as being 97.6 degrees. 2 questions left. Question 10 next. Pause the video and give this a go. Now, I'm wanting BCD, and they haven't put any letters on here. So which one do you think they'd be asking about? Well, it's not going to be this one, because that's just going to be angles in a triangle. So it's either going to be that one or that one. Which one shall we say it is? Let's call A, B, C, D. It's going to be, actually, it's probably not, is it? It's going to be something which means, well, we can just work that out. We don't need to know, we need to know this, and we need to know that length there. So they want X centimeters there, I think. Well, and they're asking us for that, so I don't suppose it matters. Let's forget about the angle. Let's just say this question's asking us that. So in order to do that, I could use Pythagoras to work out this length. And once I know that length there would be the opposite, and this length here would be the hypotenuse. So I could then use sin. So what have I got? I have got a squared plus b squared equals c squared. So there's my 20 squared. I've got, if I call this length here y, I've got 16 squared plus y squared equals that. I can do y by doing the root of, if I take 16 squared away from 20 squared, pop that in the calculator, I get exactly 12 centimeters. So then I have got, that's 12, isn't it? So we are saying so sin 25 equals 12 over the hypotenuse being x. And then I need to multiply by x to give me x sin 25 equals 12, and divide by sin 25 to give me 12 over sin 25. Pop that in the calculator, and I get 28.39. Round that gives me 28.4 centimeters. Right, we've just got question 11 left. I think we're sort of running out of time, so this would be really good for you to have a go at and upload your attempt at this to me, please. So remember, think a bit creatively. break it up. You've got two different right angled triangles. See how you get on, let me know. Okay folks, see you next time. Cheerio.